Ready? Okay. A store sells small and large ice bags. Small cost $2.75, large ones $4.50. Define the variables and state the implicit constraints. So I think you probably all agreed to this. And then just say number of. Those are the units. So we know it's discrete. The implicit constraint is that both variables have to be positive. So half a mark for each. Write the inequality that would indicate that the store owner would like to sell at least $500 worth of ice bags. So if it's dollar amounts we're talking about, then in this case you would want these as your coefficients, right? So you want 2.75x plus 450y has to be at least $500, right? That combination you would like that to be. So all or nothing today, okay? So it has to be that. Next, write the inequality that would indicate that the store owner can store at most 100 bags combined. Right, at most 100 bags combined. So that's just when we're dealing with the number of bags, right? Small ones, large ones. That has to be less than or equal to 100. Okay. No, you don't want any dollar coefficients in front of it because we're just dealing with the number of bags. Write the inequality where the store owner can carry a maximum of 45 small bags, specifically small, right? So we'll just go small. That has to be less than or equal to 45, like that. Write the inequality that would indicate that the store owner carries a minimum of 50 large bags. We're just talking large ones, and a minimum would go like this, and 50 right next to it. So that would be the inequality for that one. And normally I wouldn't tell you right, okay? It's just, I just give you a bunch of these, and you just have to figure out, oh, there's inequalities in that problem, right? So in this case, we had 4 different inequalities for this particular problem. So all or nothing there. Which region would be shaded using regular shading if you are given this? Really, it just came down to, right, you would want to divide and make sure y is just on its own, and it flips the sign. That's all you need to get to, this part. So true region is below. We're going to shade below, right? If it's regular shading, we would want to shade where the true region is. Okay. So I'll give you half a mark for this and a full mark for actually telling me where to shade. Would this be part of the solution? We just plug it in, right? So you just have to be careful. We're plugging in the negative 15 into the y there. And it has to be greater than 5 times negative 1 plus 30. And so this would be 30 greater than, this is negative 5 plus 30 is 25. So yes, it is, right? Because 25 is less than 30. All right. 1 mark for that. And then writing inequalities again. Assume regular shading. So this is true here. So we can already start with this. True is greater than because it's dashed, right? And then my y-intercept is 3 positive. And my slope in this case, did anybody figure out? I try to give you points if I can. So this is 1, 2, 3, 4, 5, 6, 7 this way. And 2 going up. So this would be 2 over 7 negative. Okay, because it's dropping from left to right. So 1 mark for the proper slope and intercept, and 1 mark for the correct symbol. For line A, in this case it's a vertical, so it would just be x is greater than dashed, right? And here we go with 3. That's the mark for that. And line B, it'd just be that one. The true region is below and it's solid. And we are below negative 2, right? So that's my mark for that one. So this is out of 12, I believe, for 5. 5 and 3 is 8, 9, 10, 11, 12. Yeah, we're out of 12 total here. So make sure you mark at the top is out of 12. You did pretty good on the first one, marking wise.